So let's discuss the question from JEE paper. The question says, what will be the correct basic strength Kb order of the following amines? So these are the 4 amines given. So their structures we can draw, and after drawing the structures we have to see that which one is having the more basic strength. See, in the like Ka is used to detect the acidic strength, the dissociation constant for acids. In the same way, Kb, the dissociation constant for bases, is used to detect the basic strength of the compounds. And here they have given the 4 compounds, so we have to compare them. To know about the basic strength, first a concept I have to discuss here, which is important for you to understand. Many are knowing it, it's very nice. If you are not hearing, something is we are utilizing in this question, so I have to tell it earlier. Basic strength. See, we have studied Lewis acid and base theory in lower classes, and that we have studied that Lewis acids are those substances which are accepting the electrons, and Lewis bases are those substances which are donating the electrons. So if you are donating the electrons easily, then you are a strong base. If you are donating the electrons less easily or less readily, then you are not such a strong acid, or then you are not such a strong base. If you are donating the electrons easily, then you are a strong base. If you are not donating the electrons easily, then you are a weak base. So on that criteria only we will be working in this question. First is phenylethanamine. So phenylethanamine looks like this. This is a phenyl group. Methanamine is this one. So this is phenylmethanamine. So let's give this first option. Then is N-dimethyl-aniline. Aniline is nothing but the benzene amine. So they are saying N-dimethyl. NCH3, NCH3. This is the second option. Third option, N-methyl-aniline. So this is N-methyl. Here it is not substituted, just hydrogen will come. N-methyl-aniline. This is the third option. Fourth is a benzenamine. This is nothing but the aniline. It is carrying a lone pair. So we are seeing here that lone pair is present on all the compounds. So here how we will decide if the lone pair is present on all the compounds, that which compound will give the lone pair easily and which will give by difficulty. So here we have to see the resonance effect, mesomeric effect, inductive effects, and all these effects. And by all these effects, if the lone pair is being easily donated, then what will happen? Then the compound will be highly basic. And by all these effects, if the lone pair is not easily donated, then it will be a less basic compound. So let's see. They are saying we have to arrange in the decreasing order of basic strength. So first we will see which will be the most basic and which will be the least basic. For this you should know the conditions for applying inductive effect and resonance and all these things. In the first compound, phenylmethanamine, in this one we can see that this lone pair of on nitrogen is not delocalized, it is localized, because there is a distance between this lone pair and the benzene ring, and for the resonance to take place there should be conjugation. For example, if I say this is a compound, okay, in this conjugation is there in between negative charge and a double bond, means the distance between a double bond and negative charge should be there. If the negative charge is far away, then no resonance can take place. Okay, so in this we can say the lone pair is not in conjugation with the double bond, so the resonance will not be able to take place. And when the resonance will not be able to take place, this lone pair will be localized on nitrogen. So this compound will be highly basic compound. Its Kb value will be very high. Okay, let's see other compounds. In the fourth compound, aniline, benzenamine, we can see that this lone pair on nitrogen will be completely involved in the resonance in the benzene ring, and this will be actively involved in the resonance in the benzene ring. So this lone pair will be not or very less available on nitrogen for donating. Thus its basic strength will be very less. Okay. In this option, we are seeing in second option the lone pair of nitrogen is there, and moreover this lone pair can be involved in the resonance in the benzene ring, and moreover there is plus I effect from the methyl groups. Due to this plus I effect, the electron density on nitrogen will increase. Due to this, it will be able to donate the electrons more easily. Thus, it will also be having a good basic strength. In third option, we can see that if there is a plus I effect of methyl, it is absent on the other side, and there is lone pair which will be involved in the resonance. Okay, so the electron density is high. Okay, but if we see the order, the maximum basic strength or Kb value will be of first option, because this lone pair will always be available because it is not in conjugation with the double bond. So this will always be available because it is not involved in the resonance. So it is the basic strength is maximum. And then we can see in second option, the lone pair is involved in resonance, but there is plus I of methyl groups. So this lone pair will be slightly more available as compared to the other options. In third option, there is plus I effect and lone pair is involved, but due to plus I effect, this will be more basic as compared to this one. And then this compound, the lone pair will be always in circulation in the ring, in resonance in the ring. So it will be available very less. The chances are very less of its availability. Thus its Kb value will be very less. Thus its basic strength will be very less. Okay. So if we are seeing the order, this will be having maximum basic strength, then second, then third, and this will be the least basic, in which the lone pairs are very less available for donation. Thus it will be having the least Kb value, or it will be having the least basic character. So the decreasing order will be 1, 2, 3 and 4. First option will be the best answer. Okay.